Well, hello. This is the continuation of chapter 1 about functions. So today we will discuss about modulus functions. Now take note that the term modulus, all right? So when we are going to find the modulus of any number, either it's a positive or negative, the result is always a positive number. Okay? Now take note that sometimes the modulus, the modulus of a number is sometimes called as an absolute value. By definition, the modulus of x, which is denoted by this symbol, is defined as x if x is greater than 0, 0 if x is equal to 0, and negative x is if x is less than 0. So what does this mean? Let's say, for example, if you are taking the modulus of positive 4, the result will always be 4. Okay? And if you're going to take the modulus of negative 4, then the result is, according to the definition, it's the negative of x, so negative of negative 4. So the result is always a positive number. So take note that when you're dealing with modulus numbers, so you will have, your answer will always be a positive number. Okay? All right? So now, if we are going to apply this to solving equations involving modulus functions, let's say, for example, in this case, in question number 1, you are trying to solve 3x plus 2 all over x plus 1 is equal to 2. Now, again, take note that earlier we said if we take the modulus of a number, it is always a positive number. So in this case, if you're dealing with this, you will need to have two cases. So what are our cases here? So cases are, first one is that 3x plus 2 all over x plus 1 is equal to 2, right? Because if this one here, which is this, is equal to 2, the modulus of 2 will also result to 2. Okay, so that is our first case. Our second case is your 3x plus 2 divided by x plus 1 is equal to negative 2. You see the difference? So this time around, your 3x, the result of your 3x plus 2 all over x plus 1 is negative 2. But take note again, going back to the definition, if we are going to take the modulus, right, of negative 2, the result is positive 2. Okay, so that's why we will have two possible values of x in here. So now let us check how are we going to simplify this. Of course, using your fractions. So this will give you, we have to cross multiply, so that will give you 2 bracket x plus 1 is equal to 3x plus 2. So this will give you 2x plus 2. So distribute your 2 is equal to 3x plus 2. And then combine all similar terms. So I'm transferring 3x to the left side. So that will become negative. And that will give you 2 minus 2 on the right side. So that will give you negative of x is equal to 0. So therefore, your x is 0. So that is your first solution. Second solution. This one is, of course, we cross multiply again. So this is all over negative 1, and then now we can cross multiply. So that will give us 3x plus 2, right, is equal to negative 2 times x plus 1. So this will give you 3x plus 2 is equal to negative 2x, distribute the minus 2, so that will give you negative 2. And again, Same algebraic manipulation, combine the like terms. So that will give you -2 minus 2. So this will become 5x equals -4. And therefore, x is -4 over 5. So you will have two possible answers for x. So therefore, you have x equals 0 and x equals -4 over 5. All right, now look at question number 2. So as you can see in question number 2, it is somehow different from question number 1. In what sense? Okay, as you can see in question number 1, the term with the modulus is isolated on one side only. Unlike in question number 2, you have an extra term here which is positive x. So what we are going to do first when you encounter this type of problem is you need to isolate the term with the modulus, okay? So what will happen is instead of having this, we have to manipulate your equation so that your expression with the modulus will be isolated. So that will give us 8 minus x. Okay, so now as you can see, this is now isolated. Right, so we will do the same thing that we did in question number 1 by having two different cases. Okay, so that means your first case will be x minus 5 is equal to 8 minus x. So it's the same thing that happened to question 1. As you can see, the term inside the modulus is equal to whatever is the term on the right side of your equation. So it's the same thing here. X minus 5 is equal to 8 minus x. Okay? And for our second case, what will happen is this x minus 5 will now be equal to the negative of the whole thing. So negative of 8 minus x. Using your algebraic manipulation, so this will be combining like terms, x plus x is 8 plus 5. So this will give us 2x equals 13, and therefore x is 13 over 2. So for the second case, that will be x minus 5 is equal to -8 plus x, because we distributed your negative sign. In other words, when we combine the like terms, so this is x minus x is equal to -8 plus 5. So x minus x is 0, and we're saying that 0 is equal to -3. However, mathematically speaking, this is not possible. So therefore, in this case, we do not have a solution for this equation. So no solution. Right? So how are we going to check? Now let us check, yeah? See. Let's check for the equation. So this is one of the good thing about mathematics, because sometimes you can check whether you got the answer correctly. So how do we check? Substitute your x, which is 13 over 2. So 13 over 2 plus modulus of 13 over 2 minus 5, correct? So this will give us 13 over 2 plus modulus. So this will give us 2, and then this will be 3 over 2, right? What is the modulus of a positive number? So that will give us 3 over 2 only. So in the end, we will get 16 over 2, which is also 8. Okay, so now we have checked your second item. Now let's move on to the last one. See the difference in question number 3. So in question number 3, what we have here is a quadratic. So it looks very complicated, right? So this is a quadratic function and it's equal to a linear function. So how are we going to do this? So it's actually the same process as what we did earlier. So now we will have two possible cases again. So I'll just put the cases this time horizontally since it's quite long. So case 1 is that we take the terms or the expression inside the modulus, and we will equate this to the expression on the right side. So that is our case number 1. So how do we do this? So this will give us x squared minus 7x. We transfer your negative x, that will become plus x, right? And then plus 6, I'm sorry, my screen is hanging. Plus 6 minus 6 is equal to 0. So in the end, we can simplify this as x squared minus 6x, and 6 minus 6 is just 0. So we can factorize this as x bracket x minus 6. So therefore, our possible values of x are 0 and positive 6. Right? Now what about for case 2? So case 2 is just the same as what we did in the last 2 items. So what we will do, we will take the expression inside the modulus, and this will be equal to the negative of whatever is on the right side. So don't forget to put a bracket all the time. So if you want to simplify this further, this will give us x squared minus 7x plus 6 is equal to, distribute the negative sign, so negative 6 plus x. And then put all of the terms on the left side. So this will give us x squared minus 7x minus x plus 6 plus 6, right, is equal to 0. So in the end, what we will have is, that will give us a 0. So this can be simplified as x squared minus 8x plus 12 is equal to 0. Using factoring, which you have learned in maths already, so this will give us x minus 6, x minus 2 is equal to 0. So therefore, possible values of x here are 6 and 2. So in the end, as your conclusion, we will have, I don't have a space anymore. So therefore, possible values of x are 0, 6, and positive 2.